Hello students, today we will cover covariance and correlation coefficient in this lecture and understanding the relationship between variables. In this presentation we will explore two statistical concepts, covariance and correlation coefficient. These concepts helps us understand the relationship between two variables in a dataset. We will delve into what covariance and correlation coefficient represent, how they are calculated, and how to interpret their values. By the end of this presentation, you will be equipped to analyze data and identify the direction and strength of the linear relationship between two variables. Covariance, denoted by in this manner COV, is a statistical measure that captures the direction and extent to which two variables change together. It tells us whether the variables tend to increase or decrease together, or if they move in opposite directions. Positive covariance signifies that when one variable increases, the other variable also tends to increase, and vice versa. Conversely, a negative covariance indicates that as one variable goes up, the other tends to go down. A covariance of zero implies that there is no linear relationship between the variables, meaning their changes and are independent of each other. It is important to note that covariance is measured in the units of the product of the two variables, which can be difficult to interpret in real-world applications. So calculating covariance. When we have sample, so we will use sample formula. When we have population, we will use the population formula. So this is the formula for covariance. Here you are seeing the C x1 minus x. These are the same formulas, but we will use n when there is population. We will use small n. This one when we have a sample. So you better should know what is a sample and population and what is the difference between them. Xi is the data value of x and yi is the data value of y. X is the mean of x and y bar is the mean of y. So covariance and correlation coefficient can be computed manually using mathematical formulas, but it can be tedious for large data sets. Statistical software packages offer convenient ways to calculate these values. The formula involves finding the mean of each variable, subtracting the mean from each data point to get deviation from the mean, and then multiplying the corresponding deviation from the mean of for each variable. The sum of these products is then divided by the number of data points minus 1 to get the covariance. There is just one tiny problem with covariance. So it could be a number like 5 or 50, but it can also be something like 0.002345 or even over 30 million, as in our example, the use of a completely different scale. Correlation coefficient. So correlation coefficient is denoted by R, and we can measure it through this formula. And perfect positive correlation is have two conditions. That correlation coefficient is equal to 1. The entire variability of one variable is explained by the other. Correlation adjusts covariance so that the relationship between the two variables becomes easy and intuitive to interpret the formulas for the correlation coefficient are the covariance divided by the product of the standard deviations of the two variables, or the correlation coefficient is then obtained by dividing the covariance by the product of the standard deviation of the two variables. Thank you so much. Please subscribe and like the channel.